Good morning, everyone. Today we are gonna to learn about the bisection method, its algorithm, its program about bisection method, and with the solved example. So let's start it. So the first question arises in everyone's head: why we find the roots of equation? So what are roots? The roots are the value of x where f of x or the function is equals to 0. So why we find the roots? Because in different fields it has different uses, like in engineering it's for structural analysis, circuit design, and in physics it's for equilibrium points, wave equation, and in economics it's for break even analysis and optimization. Now when we go to the algebraic solution are impossible or impractical, numerical method become essential. Now, what is bisection method? The bisection method is a technique that systematically halves the interval containing a roots. It requires two values, f of a and f of b, with opposite signs, meaning there must be a sign change across the interval a, b. This guarantees at least one root exists within the interval. For continuous function, the method guarantees a convergence of root. It may converge more slowly than the other methods, but it's simply reliable, making it an excellent point for numerical root finding. The interval is repeatedly halved until the desired precision is achieved. Now we will go through the its algorithm. uh, we will start the interval from a comma b and check the condition if f of b dot f of b is less than 0 or will be negative. Now we compute the midpoint here by calculating the a plus b by 2, and now evaluate f of c. If f of c is equals to 0 or f of c modulus is less than tolerance or less than our error, then root is found. If otherwise, we will go to another if else statement. If f of a into f of b is less than 0, then we change the value of b in a set of a comma b and put b equals to c, or otherwise we will change the value of a to c and repeat the interval until the width is not less than tolerance or our error value. Now we will solve an example to understand this topic. Uh, the example we take is solution f of x is equals to x square minus x minus 1 equals to 0. This polynomial is continuous everywhere, make it suitable for the bisection method. This positive root is expected near the golden ratio, that is 1.618. We will find the root that lies between x equals to 1 and x equals to 2. Now we calculate the text points where the f of 0 and is coming negative, f of 1 is coming negative. If we take these two values, then the f of a in f of 0 into f of 1 is equals to is greater than 0, so it's not compatible. So we take f of 2, which is positive, and satisfy our conditions. So now sign change detected between the x equals to 1 and x equals to 2. Since f of 1 is less than 0 and f of 2 is greater than 0, the function crosses 0. Now by the intermediate value theorem, a root exists in between 1 comma 2. By the intermediate value theorem, a root exists in 1 comma 2. This interval becomes our starting bracket a comma b. So here the graph that shows the value of a, b and c and f of c. You can see here the f of c value, how is the calculation goes, and here you can see how the bisection method works. It halves the value again, and then with new interval it also halves this and again, and it converges to a uh, final solution point. Each iteration halves the interval containing the roots, as we have seen in the graph. Now we go to the actual solving by using the tables. Here we make a table with one column with iteration, with value of a and with value of b, and value of c and f of c and new interval. Here we first in first iteration we take 1 and 2 as the value of a and b. Now calculate c by a plus b by 2 and calculate f of c. As you've seen, f of c is greater than 0, so we change the value of b equals to c. As you can see, the what the new interval came, and now we can put the new interval here and calculate again c and f of c. Here it is less than 0, so we can change the value of a and do not change the value of b. Perform these iteration until the seventh iteration. Here we find our final value, it came to uh, f where it is f of c 1.3672, where our f of c is less than our tolerance. So approximate root is equals to 1.618, the golden ratio, and the exact root equals to 1 plus root 5 by 2, that is 1.618, and minus 0.618. Here, by performing the 7 iterations, we find the approximate root. Exact root of x square minus x equals to 1 plus root 5 by 2, that is 1.618, and 1 minus root 5 by 2, that is close to minus 0.618. The convergence behavior is games at the 2 to 1 and 1 to 0.5 and then 0.25. Now we come to the Python code. Now we define the function, that is f of x, which returns the our equation x to the power 2 minus x minus 1. Now we define the another function, that is bisection, with taking arguments like f, a, b, tolerance, and maximum iterations. For I in range of maximum iteration, we start a for loop where the c equals to a plus b by 2, computing the midpoint. F of c is fc equals to f of c. Evaluate the f of c. We are calling the first function, and now print the information about the iteration, and that what is our iteration number, what is our a, and what is c, and what is f of c. If the f of c is less than the tolerance, we will return the c as it is our final value. And if we will check the condition with f of a into f of c and change the value of b and c accordingly. Now we will create now we will call the bisection with giving the values of f1 comma b, and print the root 6 of f, as the root value comes from this. So now the summary for our full video is that the bisection is simple and reliable. It guarantees a convergence continuous function. The error halves each iteration, making it predictable but potentially slower than other methods. Practice applying these technique to other polynomials is strengthen your understanding for faster convergence. Explore advanced numerical methods such as Newton-Raphson and secant method, which we are going to learn further. And these methods offer speed advantages but require a careful consideration of initial guesses. Thank you. If there are any question, you can ask in the comment section. And this is the appendix Python code for you all. Just go through it. Okay, thank you.